Hello everyone. Uh, I hope that video and audio is clear to you guys. Please let me know in the comment section and we will start in 2 minutes. Just wait for the other user. Please let me know about the audio and video. Hello. Please let me know how's the audio and video quality is so we can start. Okay, so I guess we can start with our session. So let's go ahead. So if you are following our series, so you have seen that we are doing a project on customer churn prediction. We are building a model who can predict who's customer, who are the customers who can leave our mobile phone operator or company. So till we have done with the planning phase, and today we will try to complete the data processing phase by fully, which is the second phase in the MDLC, that is model development lifecycle. So let's go ahead and start with our session. So till in the previous session, we have read our CSV text file into our data set, and we have converted into a data frame, Panda data frame. So we can see visualize it fully. And also we have done like a little bit operation to find out the columns of that data frame, and we are able to done it. Also before that we updated our packages, and also we created our requirements.txt file. So these packages can be installed with a single command, pip install dash r requirement.txt. Using that command we can install all these packages with just one command. Okay, so today we will try to complete all the full data processing phase. So first, as we can see, like in our data set, which is like this one, we have converted into this data frame. These we as we already discussed, these are the features of our data set: state, account length, area code, because these are just basically representing uh, is going to tell like our model how on what basis it has to calculate or be it has to make a prediction, and this is our label. So this part we have already discussed in the previous session. So you can see these features are generally of two type. One is the categorical feature and one is numerical feature, in especially in our data set. So you can see this is a category data set. This is nothing has to do with the numeric, like a state, it is just category. Also account length, so this is the basically number of days, so it is a numeric feature. Similarly, area code, it is seems like a numeric feature, but it is an categorical feature. Why? Because area code is just representing a particular area. So it can be represented by A, B, C or X, Y, Z, but it does not give me any numerical benefits, right? So that's why area code is also a categorical feature. Similarly, phone number, it does not add any value to if any customer is going to leave or not, right? So we have to basically clean all these data set. So uh, to start with, first we have to do the to use first, if you just wanted to see the numeric features, you have to use this command called first describe, not command, just the function, describe function. So we can type describe and okay. So you can see all the numeric commands, and it display basically a statistical calculation summary. So it displays mean, total number of count, standard deviation, minimum values, 25% values, and 55. So, and basically a little bit of summary of all the statistical operations or statistical calculations which we can do with our data, right? So, um, so you can see state is not there because that, as we already discussed, it is not a numerical feature. Okay, so you can see it is a mean and standard deviation. So here, let's look at the data, like if it is a properly distributed or evenly distributed or not. So if you look at account length, there is sufficient data at the 25% means like 25% of data, like some data is allocated below 25% of that, and 50% or at the 50% range also there is some data. At 75% there is also some data, right? Means some people, we why we are checking this, because we want to check like if the data is not biased or not. Like if suppose this account length here, this account length is representing like number of days people have used this phone number or this account basically. So 25, there are some people who used it for the just 25% of all the data which we have, and there are 101 records which we have, which is like at the 50% of the, who uses like the maximum is 243, right? So there are some people who use 50% of that, and there are some people who used it at the 75% out of like total 3,333 accounts, right? So you can see some people have used it for 128 days, some people use it for 107 days, some people use it for 137 days. So like similarly, this just give you a brief overview, like our data is distributed evenly or not. So if you look at this area code, are they coming from the different areas or not? So we can see here properly. Okay, yeah, so everywhere, like some data is coming from the other 25%, some is coming from the 15% and 75%. So we can see like data is properly distributed. However, we can see in the case of vmail message, like there is no zero data here, and all the data is coming from the higher end. Means either people are not utilizing at all, and suddenly they are utilizing much more. Like there is no data available for the less uses of email message. So we have to check why is that so. So as we can see, because some users have not opted for the like voicemail plan, correct? So they are not utilizing as they have no. So like there is data available all zero. But who have opted for it, they are utilizing it extensively. So that's why it is a data is showing like this. So this is not a bias. This is just a condition, and like basically our model has to detect this pattern, right? This is not creating any biasness into it. But here, if we look at the area code, if like more and more data coming from a single area, so we can say, okay, this model will predict more of a like it is biased toward a particular state or particular pin code, right? So we are just checking that. So here also it is like data is coming from each of the state, and similarly everywhere I can see like it is properly distributed everywhere evenly, like we have data a little bit of everything. So like it's a really good thing. We don't need to distribute it evenly by ourselves. Okay. So as now we are done with that. So now let's start exploring our data, and let's see like what else we can do. So we can see like this area code, as we discussed, it is not of much use to us, right? So what we can do, we can drop off this area code. So to basically drop this area code, just give me, yeah. And also, even though I just see like this phone is a numerical feature, seems like a numeric feature, but it is a categorical feature because you can see it is not coming under this numerical feature describe function. Why? Because it is just representing an identification. It is just a category. Even like this phone number is not affecting any numerical calculation, right? It is not treated as a number here. It is considered, it is an like an object data type here. Like it is just for the identification of the user, right? So what we can do, we can remove this phone from our like data set. Okay. So to do that, what we will do, you will utilize the drop function. Okay. So we will do churn drop, and then we have to type the like column name, which is phone. Make sure you follow like the P is capital, so you have to provide that. And also we want to remove it from the column, so we have to provide axis 1. If it you have to remove it from the row, then you have to provide axis equal to 0. Okay. So if we will do that, and let me like replace it with the original value churn. Okay. So let me just do it. And now if I try to run churn, you can see phone has been removed from our data set. Okay. Another thing as also area code is also it is treating it as a like numeric value, but it is not a numerical value, right? It is not just like dim nets. We can detect the pattern. Okay, they are utilizing minutes, that much minutes. So that's why they might not looking for a they are taking the advantage over mobile phone services, and they are not looking for the churn. But area code is not that kind of data, like numerical data. It is the categorical data, just like in state. We have to consider it, but not in a numerical form. So that means we have to like convert this data type, right? So to do that, we have to just convert this to an object data type. Currently, it is in a numerical data type, so we have to convert into an object data type. So for that, what we will do, we have to just put the column name into a square bracket, area code. Just make sure about the capital letters and all. This is the common mistake which I see. And we want to utilize as type as I said, object. Currently it is an uh, like a numerical data type, so we are converting it to like object data type, right? And we just replace it with area code column. Okay. And when I press shift enter, and now if I try to do churn, so you can see still it is showing, but to like detect it has been converted to object data type or not, what we have to do, we have to like describe it, because describe function only give the statistical calculation overview of numerical features only. Okay. So when I do that, so you can see earlier it is when I do the describe, it is showing me area code as well, but now it is not showing me the area code. Okay. So numerical feature wise, it's look good to us. So we can go ahead. Or maybe we can also like look into the graphical way possible. So it will be like more easier us to for us to find out every like other relationship. But first, as we already covered the numerical features, now we will see about the other categorical features which we have in our data set. So just like we have state, area code, we have already converted and all this. Okay. Phone, we have already removed it. Okay. So like let's first convert like let's see for the like our like all these categorical features, or you can say object data type basically, right? So to do that, we have to like utilize our pandas library. So what we will do with pd dot cross tab. So we will utilize this cross tab functionality of our um, what we can say our panda package basically. So like does anybody know about this cross tab function, like what it actually do? So basically it generate a frequency table. So what is this is what is this frequency table? So when we like generate it, we will see. But basically, it tells like we have read in the our 10th class mathematics or 12th class mathematics, or maybe if you have done engineering also, then in that mathematics, like it gives you like how many observations we have of that particular thing, right? So like generally we know like probability of everything occurs can be one, right? Like if there is like possibility of yes and no, like then the total of that is always be equal to one. Like if we can see like any customer can leave or any customer cannot leave, so like probability will be 0.5 or to 0.5. So something like similar to like this. So we want to check this data, right? Because like this churn is also like we this is churn is also a categorical feature, like categorical label. So we want to see like if it is giving both the datas or not. Like at least it should give almost 50% of data like data of those customer who have already left, and 50% of data who are customer who are still with the company. Okay. So we want to like check if there is no like we are having the like our data covers all the uh, proper scenarios, and it should not be biased and not redundant. Okay. So let's utilize this cross tab, and what we have to do, we have to like as I wanted to do it for the all categorical features. So like I will what will I do? I will utilize the for loop. Okay. Wait, I just ran it. So first, before that, I will utilize the for loop. So for column in, and my data set name is churn. And why I'll do, I select the data type of objects, right? Because that is representing my categorical features. So include, and I will provide in the square brackets as object. Okay, not columns. And in the like Python, we know indentation can start the loop, and then here index equal to turn of column. So it will take every column and just give me data about every column. So I don't have to do it for every column, right? And then what will I like represent that probability using? I will use the like observations. Okay. So maybe like percentage observations. And also I will normalize it with the columns. Okay. Yes, it is complete, and I also have to display it. So what will I do? I will display it as well. Okay, I will utilize this display functionality. So let me press Shift Enter. Okay, there is some error. Okay, here I'm not like just a spelling mistake. Okay, so here you can see like of the AK state we have like a 0.015 data. So like you can see all data is 0.0 something. So like it is seems like it is a properly distributed. Similarly, as I talked about churn, so seems like 0.5% of data is from the like who have like not left the organization. I guess it is because we have already dropped this phone, so we have already removed some data because I have checked it. So what we can do, we can again like utilize again read it, so it will be easier for us. And if I try to do it right now as well, like we will run this phone command later because it is as we remove this phone column from our it has removed some data for us. Okay, so now if I try to run it, oh, it is giving some data related to that only. So like basically it is giving us that it has more data of like people not leaving our organization, and there are some like very few data about like which has left the organization. So generally we will look for more data who has not left the like who has left the organization, because there we have less data. So we will demand the more data from our team and we will provide it, because like that will give you because now if like we are using this data, so it will be more inclined towards not leaving the organization, right? It will not provide the correct data. But as now like we don't have that much data set, we are only utilizing this data set, and this data set is like seems like not a proper data set, and it is slightly biased, so our model will be also trained slightly at the bias stage. As far as like I checked it last time, I don't know how it is coming like that. Anyway, okay. So, but like if you have, then you have to demand more data if it according to that. Okay. So same, you need to see on your if you want to make a histogram out of it, so you can do that as well. So for that, wait, just give me a moment. So like so for new like numerical features, what we can do, we can create a histogram as well. So what is histogram? Histogram is basically a representation of the distribution of data, that how that numerical data is has been distributed. So just like I can show you by creating an histogram, we can do churn dot st. We can utilize the his function. So you can see it is giving me some little bit of histogram, basically graphs. But you can see this is little bit congested, and these are not very aligned, very well aligned and presentable. So we have to add some parameters to this hist function so it can be more presentable and more utilized for us. So if you just provide like fixed size basically figure size. So let me try it like let me include here fixed size. So it is basically take width into like height into inches. So what I will do, I will set it to first 10 by 10. Okay, and just try to run it. So you can see now it is more broadly defined, right? So now we can see it more properly. However, there is also some space left. So maybe we can like increase the width as well. Okay, so width is the first argument. So now you can see it is now more properly defined. Also, we can like I can see very less bins are there. Like if you don't know bin, basically I meaning this bar, basically which represent the interval or range in which this data is divided. Okay, basically these data points are like on what basis they are counted or aggregated within each bin to like create a visual representation of like proper distribution of this data. Okay. So like default value of this is like 10. So like currently you can see there are 10 like these pillars you can see like in simple language these 10 pillars generally it is distributed into that. But let us like increase it so we can see it more properly. So I will do bins equal to 30. So now it is like giving me much more data. And as you can see, like basically this every data you can see this is in a like bell shape distribution, which is also known as Gaussian distribution or normal distribution, right? Because this is a nor if yeah you distribute your data properly, it will always come in a bell shape. Like even like this is a like a very real phenomena. Even if you go to YouTube and you search for normal distribution live, let me just show you. So yeah,
We all get born into very similar conditions, but some of us will live past 100,
so if
while
you just
most won't
put
even
it,
make it over their 70s.
you can
This
see
is what they
it.
call a normal distribution. But unlike these balls and pegs, we don't have to be.
You can see always this data, like if you distribute anything, it will always come into this curvy form or in this bell curve form naturally. Okay, I don't want to get this copyright strike. So you can see that that represent that it is normally distributed. So all data is like in this bell-shaped curve except this female message. And we already seen why is that so? Because some have not even chooses it. So that's why more data is like coming for like there is no data for like who has not chooses this female plan, and there is data like they are utilizing extensively who has opted for this plan. So that means it is okay. So that there can be exception to it. It depends on what is the use case of that particular feature. Okay. So mm, so we mail message can be utilized that. So now let's see our churn data set. And yeah, I have included the phone number again. So I have to drop it. I just thought like the data set is I done some mistake, but it is not properly distributed for us. So let me just like drop this phone number from here. Okay, so now let me run this data set. So phone number has been dropped, and area code also we have converted it to like this area code is also included here into the numeric feature. So let me just check churn dot describe. Yeah, so area code we have already converted it to like this one area, even though it looks like a numerical feature, it is a categorical features. Okay, so this part we have already done it. So now what we will do, we will basically look at the like difference. Basically, now as we can see, like there is some day calls, day charge, day minutes, and evening minutes, evening call, and evening charge. So, like, what is this representing? There is no need of like this representing this charge, right? Why I'm saying this? Because if you see, like, when we are calculating like how many minutes they are utilizing, so this is a meaningful data for me. How many calls they make, this is also like very good data for me. But when I am using this data day charge again, it is basically coming out of this minutes and calls only, right? It is like how minutes they call and how many calls they have make. It is just a repetition of this data in another form. So this is making my model more biased towards this day charges, and like they will be more like it will detect the pattern into this, and same pattern will come into this, right? Because eventually it is just a multiplication of these terms only. Similarly for the evening charge and similarly for the night charge. So I have to drop all these charges, and also same for the international charges, because we will detect the same pattern into international minutes and the international call. That's how, like if the calls are increasing and minutes are increasing, then call charge will also increase, right? So there is no like a need for like doing it again, because otherwise it will make our model to like more biased towards this. So what we have to do, we have to drop off this. So let me just copy it. Also, you can drop like multiple columns by doing this. So you can do mm, day charge, okay, and just you have to include a comma, and just you can put another like column name. So what is this? Evening charge, and also for the night charge as well. Same we will do for the international charge as well. Okay, and we will try to like display it again. So we check churn data frame down from but take 5% in keyword. Okay, it is saying that it can take only one. Okay, so okay, because okay, so what we'll do, I will send it as a like inside a square bracket, so it will take as a single positional. Okay, so let's do it. Okay, yes, so you can see now that like charges columns has been removed from it. Okay, so now we have cleaned our data set. So uh, now let's to determine which algorithm second thing which come, like which algorithm we have to choose, right? So like we can see like there is a like some variables which have like a properly distributed high and low, and every like it has mostly every kind of data. And in an like basically in order to accommodate this in an algorithm, basically like in linear regression, we need to generate a polynomial or bucket terms. So instead, let's attempt to model this problem using gradient boosted trees. So like SageMaker has this container or algorithm called XGBoost, which is like very popular for gradient boosting, which can be used to train in a managed and distributed setting. And we can also host it as a real-time prediction endpoint, right? So basically, this XGBoost uses this gradient boosted trees, which naturally account for non-linear relationship between features and target. So because there is no linear relationship between these features and the target variable, right? Okay. So for that use cases, this XGBoost algorithm is like basically really good for to use. So we are going to utilize this XGBoost dataset. Not dataset, XGBoost like algorithm basically. Okay. So I hope you get this point. What is the like this algorithm? So basically, we have to select the algorithm based on this data. As we can see, like this is properly distributed, and like we have to like this is a like a non-linear kind of data, so we need a gradient boost, which is like the in this most popular is XGBoost algorithm. So we have selected this XGBoost algorithm to like uh, apply our data set on. Okay. So for that, we have to convert our categorical data, like just like this area code and this state into numerical data, numerical features, basically, right? So to do that, what we have to do, we have to utilize this Panda library's get dummy function. So we will create another like to fit our data model data, and we will do pd get dummies. Yes, this. And inside that we will put our data set. Let's display it. So now you can see okay, there is some dot dot dot, so because it is not displaying fully. So to display this table fully, what we have to do, wait, uh, we have to use this panda set option function to display like maximum so we will do panda set option this functionality, and here we will put for the display functionality display dot maximum columns. Okay, we will put set 500, so every however columns will there, however we can see there is just 71 columns, but we will be able to see it. So now if I try to display model data, it will display me all columns. Okay, I can see not just this dot dot dot. Okay, so now we have converted our categorical data like this state case into numerical data, just like here you can see AK, like this first one is case data, case state data set. So on the state case it will show as true, or for and for the rest of all it will show as like false. So where is this state case? So you can see it is showing true and rest all are showing false. So now it is now that categorical data is started making sense to us in a mathematical format, because model only take those data for us, right? It basically understand numbers more. So we have to, so it can detect a pattern into it basically, right? It will be easier for our model to detect a pattern into it. So we have converted it. Same for the area code as well. And the same for the like international plan, no, like it has selected no. So it for it is true, and when it is true, then plan for yes will be false. Of course, it will be like reciprocal in every case. Similarly, we have like our label also, like this is getting churned. So it is saying in the case of false, this is not getting churned. Yes, it is not getting churned. And here, is it getting churned? No, it is not getting churned. So both are same thing, but it is now in just a numerical format. We have converted using this get dummies functionality. Okay. I hope this is clear to guys, but if you have any doubt, please let me know in the comment section, so maybe I will can explain this into like next functionality. Okay, sorry Pawan, I miss your messages. Like so like some queries, please. Okay, got it. How, sir, how does the real data analysis work here? How can we do it for the real time change? Sorry, I did miss for like which timestamp you have put it. But like if from now on, if you have any doubt, please let me know so I can like explore you. But like, did you get it till now? Like how we converted into this? Okay, okay. Thank you, Pawan. Like, do you have a, but you got this point, like how, why I need to convert this into this categorical data, like basically string type of data into numerical data. Okay, okay. Thank you, Pawan. I got it, sir. You said. So now as we have done it, so what will I do? I will basically utilize it, not utilize it, basically I will convert into a different, mm, like basically I don't require this also, right? Like I just have to predict it is getting churned off or not. So like this also is not useful for me, churn false. Like this also is doing same thing. Like with was using this also, I can find out like is like this is getting churned off or not. So what will I do? I will like drop this off, and I will bring this as a first column. Okay, so and so to do that, what will I have to do? I have to basically utilize this as a, like as we already see like how we can drop off it. So what will I do now? It is a model data, and to drop off we have to utilize the drop functionality. So we have to use drop, and what we want to drop basically, we have to, drop the like churn false and churn true. Okay, but like I want a full data about this, right? So what will the better thing would be, like if I concatenate it, then it would be much better, right? Along the like column axis. Correct. So what will I do? I will concatenate it more. So for to do that, just let me type it, so and then I will explain it in detail. Okay. I will concatenate model underscore data. So there is, yes, there is it side it. What is that column name? Churn question mark underscore true. Churn. me just copy it from here. Okay, it has dot as well, so I have to put dot. And just make sure you also don't get confused with this bracket where you have to put all these. Okay, and then I will concatenate this model data. So what I am doing, I am just taking this model data which I am seeing here, and just concatenating all the columns of this data frame along the column axis. So what will it will take? It will take it at the first as the like this column at the first before every. Currently it is at the last column, right? So currently I am putting at the very first, and then like it will be followed by all other columns except what I'm going to put it now, which is basically uh, all the data, like all this model data, and then I will utilize that drop functionality to drop this off. Okay, so now I want all the data except these two terms because this I already sent the very at the very first, right? So now I will put this column name and this column name again as well, right? Here I done, and along the, I guess, like for, I guess, just you guys tell me, for columns we have to utilize the axis one, correct? And also I want to concatenate it along the axis one only, right? So axis one means columns. So if I run it, and now if I try to display it, so yes, you can see. Wha- So basically what I have done, I have just like take this churn dot true, the last column, and put it ahead. Basically concat here means addition. So what I have done, I have add this column first at the starting by using this here. You can see churn dot true, and then in again adding with this same table and just removing these two columns along the like along the column. That's why I utilize this axis one. Okay, you got it. First I put it at the starting and then remove this column. So then I will get this one. Okay, I hope you got this because earlier, if you see, we have 71 columns. So one column I removed from behind and put it ahead, and two columns I removed. So total now it will come 70 columns. So you can see 70 columns here. Why I do it so? Because I have to like put the that XGBoost algorithm which you are going to utilize. It like have the predictor variable in the first column. Okay. So that's why I have to put it in the first row. That's the algorithm requirement. Okay. So now, and what we have to do, we have to like now we have a data set ready and it is very clean. It has all the useful data which we want and into a numerical terms as well. So that is utilizable terms. Basically, it's not like AK. So what algorithms need to do now? It will understand. Okay, it is not from the AK state. It is not from the AL state, or it is from that particular state. So it can easily understand. It is in in such a language that it can understand it. SageMaker definitely affirmative. I didn't get your issue, Pawan. Like, what do you mean by SageMaker definitely affirmative? Now, okay, you are just affirmative to like what I'm stating, or how is it? Please clarify to like what you are saying. Okay, okay. So like now we have a data set, so we have to now split our data set. So why we want to split our data set? Can anybody tell me like why we need to like I want to split our data set? Because I wanted to SageMaker integration with the algorithm. Yeah, it is already been included. Yes, Pawan, you want to tell me like why we want to split the data set here? Okay, you can type in the comments and till at that point of time I can explain. So basically, we are going to like split this model data into three type of data set. That is training data set and test data set and validation data set. So like first train data set is to train our model, which data set we are going to use to train our model. Second data set is we are going to utilize in the data evaluation like model evaluation phase to evaluate the performance of our finally trained model, right? We need some data to check like if it is properly working or not, right? And we only have this data set to check it. So we will separate it and split this data set into like three form. So later we can check it. And third one is the validation set data set, which is used like during the training phase to fine tune our model, hyperparameters, and like basically prevent overfitting. So like those of you don't know what is hyperparameter. So basically these are the like just first understand what are the parameters. Okay. So parameters are okay, let me just show you on the screen. Yes. So parameters are the internal variables that a model learned from the training data. Okay, so all these variables which we can see, so model is learning from this. So parameters or like model will automatically detect. Okay, and these are the values that the machine learning algorithm adjusts during like training process. What we are seeing, so it can make prediction on new and unseen data. Correct. But hyperparameters are the external configuration settings which are not they are going to learn from the data which we are providing here from the data set, but we have to provide from our like how we want to influence the behavior of model, which is not like applicable into data, and how we want our model to learn basically. So we will when we utilize these hyperparameters I will going to tell you more. But like we require basically we every data set generally we split into three type of data set: training data set, test data set, and validation data set. Okay, and to do that what we have to do, we have to like utilize this uh, basically we can utilize the numpy here. Till now for our data science explanatory we are utilizing this panda package. Now we are going to utilize the numpy. So first let's import the numpy package as np, which is the generalized way to do that. Yes. Okay, I have opened it since yesterday, maybe that's why it is causing some issue. We will check it. But anyway, we have imported our like NumPy library, and what we have to do now, we have to just basically split this data set, and to split it, we have to basic wait, yeah, we have to utilize this np dot split functionality. Okay, and what we have to split, we have to split this model data, so I will put model data. Okay, and here we have to define some parameters here, so it can be properly divided into like all the three data set, which is our basically the requirement. Okay, and as we have to split into three data sets, so just let me just store into these three different type of variable. First is the train data, second is the validation data which we use for the fine tuning purpose, and last is the test data. So I will store our three data set after splitting into this. Okay, I hope this is very clear to you guys. So now as we have done with the splitting, like we have provide basically we are utilizing this model data to split it, but we have to basically shuffle this data set, right? We have to properly utilize this to uh, like even if you want to replicate it at any point of time, so what we have to do, we have to put a randomized seed into it, so it will give a same result every single time. So to use that, we have to utilize the random parameter basically. And to do that, what we have to do, we have to uh, inside it, I will do utilize the sample, and then here I will provide the fraction equal to 1, then a random state. So any number, what we can put, maybe 1700, any number you can put. So but like if you want to, like, because we are just shuffling the data, so it will not get basically uh, like uh, in a particular order or every time, but we want that shuffling into a proper manner, so every time it gets shuffled into the same manner, right? So like let's take an example. If we are shuffling just like I shuffled only these three columns, 0 1 2, so it can be shuffled into 210 201 or 120 something like this. But suppose I just labeled it as 210 reverse as 1700. So every time I put random state at 1700, it will always come as 210. However, it is randomized, but that randomness is also like controlled. I am controlling that randomness here. You can treat it as like that. Like I hope you understand. Basically, I try to control the randomness of the data using in how many ways it can shuffle. So I just label it anytime accordingly. So even like later stage, I have to find out I on in what state I have randomized it. So basically, it's just a method to control that randomization. Okay, and just fraction 1 here is representing like I want to sample the entire data frame, means or I want to include all the rows. Okay, and this is the random seed for the basically reproducibility. Okay, and now after I have done with this, so I have also like provide the like how many percentage of data I have to include into training data set, how many percentage of data I want to split into validation data set, and how many percentage of into test data set. Okay, so to do that, I have to like basically provide like these percentage. So here I can do this into a square bracket. I have to put int. So inside it, yes. So I can like divide it by 70% will go to of this what I can say of the length of, as we can see, we can find out the length of the our data set using length model data. So 70% I want to go into this training data set. Okay, and then remaining 90%. Okay, I want to go into same validation data set. Oh, length of model data. So I hope I close all the brackets. Okay, here I'm not. And like remaining will be converted into test data set. So I guess this is fine. Let's try to run it and we will see. So it is giving that future warning, but it will work. Okay, it has been already been processed. So now if I see the train data, you can see now it has 2,333 rows. Earlier it has total has 3,333. And if I check the validation data, so it has the remaining 666 rows. And now last is our test data. So it has 334 rows and all has 70 columns because like we are distributing the data. So our data set has been distributed properly into different training data set, validation data set, and the test data set. Okay. And so this way you can split your data set. And if now what you can do, you can basically upload this data set to S3. So we will do in the like next session. So I hope you enjoy the session till now here, and Let's see all in the next video. I hope you enjoyed it. But if you still have any doubt, because today's session was like way more complicated than previous session, so I can expect some doubt here. So please let me know in the comments so I can resolve them in the next session. See you guys in the next video. Make sure to like and subscribe the video so we can like talk about invest later, and we can go into much more deep. There is no need to go into much hurry. But today session, I guess it was much more complicated for especially for the freshers. But I try to simplify it. But if still you have any doubt, please let me know in the comments. I will try to resolve it. Thank you so much, guys. Thank you so much for watching here.